I think I'm live. And this may or may not be working. Let me go ahead and check Discord. Either that or I am recording either way. So I'll be posting this up to YouTube after. And I'm curious what this actually picks up for me. So if I go to Twitch, not Twitter, Twitch, and see what this looks like. Hopefully you guys can hear me. All right. Channels. All right. There we go. It sounds like it can hear me when I listen to myself on Twitch stream, so I'm just going to go from there. Is there anything else I can do to make this audio a little bit louder? Suppose I could get this mic a little bit closer to my face, probably turn a little bit this way. Other than that, we're just going to get at it. And I'm not going to watch myself on Twitch stream. We're just going to start programming and see what happens. I do have my Twitch chat up into VS Code, which I'm pretty excited about. This is my first time using that, so we'll see. Actually, I should probably roll up the old sleeves. I should probably see what my Twitch settings are. Stream. It's been a while since I've done this, so stick with me. We're gonna go to my stream, and I can already hear my fan kicking up. My computer does not like. My computer does not like the streaming and programming. I tried this once before where I was doing some app development on stream, and that did not work super well. But we're gonna edit this because I should probably go to the programming. Come on, there's got to be computer science maybe. I forget what it was called. Let's see. Computer. Oh, science and programming, I think it was. We're looking for the category. It's been a while since I've been on the Twitch scene. Yeah, now it's just taking forever to load. I was thinking about doing this on my main channel, and I may still move it over to my main channel at some point, but the reason there's a little bit of a difference is because my main channel is built up to be mostly a fitness platform and not so much the development side of things, so I figured keeping it separate made sense, but that doesn't seem to be equivalent. Oh, right. It's science and programming, so we should probably put on the glasses. And Twitch straight up isn't loading for me. Come on, Twitch. God, I need to make this look a little bit nicer. Oh man, I am getting absolute trash kilobits per second. That's what happens when I do it out of my apartment, I suppose. We need to just upgrade our internet service. All right, well, I'm just gonna get started because I can't get Twitch to do anything that I needed to. Okay, so we're gonna see if this will work or not. Like I said, my kilobits per second is absolutely trash right now. Let's see, I'm plugged in. I'm wondering if like open my door if I get any better Wi-Fi signal. And I may have to at some point just also upgrade my internet, but we're gonna say that's okay. I'm in the green for kilobits per second. And Willie's here. All right, perfect. That's the whole crew. Let's see if this works. This is pretty sweet. You're gonna have to let me know like how laggy it is, or if you can hear me or not hear me. I didn't put a whole lot of production value into this one, because I figured it's the first shot. But what the plan is for today is we're gonna make a Diamond Hands program, and we're gonna get as far as we can. The basic premise is very much, let's say you have an NFT that you do not want to sell. And you just want to sit on it for an extended amount of time, well, we can make a program that basically enforces that for you to where you lock it in an escrow account until that time arises that you can then sell it. And we can like have some fun, and if you have any suggestions on how we make this theoretical account, we can do that too, of course. And just be completely upfront. I'm going to do as well as I can, doing everything from scratch. I may be pulling parts from other pieces of code I've written just to speed things up a little bit, or if we can remember. But the idea of this is very much just to kind of explain what's going on and have some fun along the way. I know I don't have any like music playing, so you're just going to have to listen to me drone on about programming. But Willie's here, and he says the bit rate is good enough, and that's all we need. So, first thing to start off, if you're going to get into Solana development, is we use a programming language called Rust. And Rust is, if you know anything about programming, think of it as like a newer version of C. And how that kind of ranks in the hierarchy is, you know, at the very basis of a computer, you have the actual machines, the hardware, and then you have basically machine code that goes on top of that, tells the thing to do. One step above that is assembly, and then you have compiled languages like C and then Rust. And the ones that a lot of people are used to are like the JavaScript, TypeScripts, Java, and all kind of web programming languages. Those are your high-end ones. So we're lower on the spectrum, and that's because, one, we need a compiled language for the Solana blockchain to actually run, and we need to be very performant. So that's why I'm speculating why they used Rust as opposed to something else. Ethereum, I know they actually created their own kind of language to do the same thing, but the nice thing about Solana is they already use a well-known development language. So that's what you need to know there, and we are going to be using what's called Anchor, which is basically kind of a framework to really help us out and speed up the development of the actual Solana programs. They take care of a lot of the headaches that we would have normally had to go around, and gets rid of a lot of the redundant type code that we would have need to have written. So we're going to go ahead and we're going to start up a project. We're going to do that. And if you want to follow along, I'll probably put this up on GitHub or something at some point. But we're just going to start from absolute scratch using Anchor. There's plenty of tutorials on how to install that. We're going to use Anchor, TS Node. I'm thinking what else we might need. Of course, the entire Rust development. And that takes a while to install, but once you get it all, we're there. So we're going to go call Anchor init. And one thing that's helpful if you're new to programming or just working on things, and also another thought, VS Code. I've been doing coding for a long time, and it is by far the best IDE I've ever used, and it's not even technically an IDE. But when you're working in the terminal, one thing I always kind of like to start off with when I'm trying to like learn something new is see what type of commands there are. So we can go just Anchor, and it's going to tell us all the things that it can do. So we have build, cluster, deploy, and a lot of this stuff, you don't actually have to pay attention to until you figure out what it's going for. But a couple things I want to just point out is we have provider cluster and then provider wallet. The wallet is something that I have spun up, and actually let's just create a new one. So we're gonna go, and I know I'm all over the place. I should probably have had like a lesson plan or something like that. So we're just gonna go from there. But we're gonna go Solana -keygen new. I believe it's just new. And that's going to overwrite my old path, which is fine because right now I'm on DevNet, which means basically everything that we do is just from the actual DevNet. And that's one of the really cool parts about Solana is you have mainnet, and that's where everything is live. You have DevNet, and then you have testnet. And those two places you can test things freely without actually spending a bunch of money trying to do it. So that's super nice. And Willie, if like some of these things and you want me to just like skip forward to stuff, feel free to just call me out on it. I don't know how much to explain or how much to leave up to the imagination. And same goes for if you have any questions, just shout them out. Solana keygen new, and we're gonna put force like it tells us to because I don't care about that old key pair. Let's see. It's not Anchor. Solana keygen new force. There we go. And I don't like saving any of those things. All right, perfect. Glad to hear that. All right, so now we basically have a new Solana wallet, which I guess I'll just go through and explain kind of the Solana terminal a little bit. This is the Solana CLI. You can, of course, if you Google Solana and figure out how to install it in your terminal, it's extremely helpful, and you really can't do a whole lot without having a basic understanding of what that does, and then you can kind of bring that learning forward. So first thing we're going to do is we're just going to take a look at these wallets. So if you're familiar with Solana, we can actually take a look at these wallets themselves. So right now I did Solana balance, which basically means the new wallet that I just came up with has 0 SOL in it, which, I mean, that would make sense, right? Because I just made the thing. But we'll need some amount because every transaction, of course, costs some SOL. We're going to need to put some into that account. So we have this super nice helper function called Solana airdrop. And then we're going to put 2 because I believe that's the max you can airdrop at a time. We can double check that in a second. But since I'm on DevNet, it just gives me the SOL that I need. So if we go Solana balance again, we should see that it says 2 again when it clears. So the nice thing is when we're on DevNet, it's actually working on Solana. It's just working on a like non-tracked version that has no real monetary value, and it's limited to certain points. But so let's try 3. Maybe it'll let me do 3, and I can. Unchanged. I want to say I went through this one time before, but 4 is a good place to start. And one thing that's kind of important to know is with Solana, everything is an account. So your wallet is an account, programs are accounts, and they all have different thought processes and how they actually work. So we're going to go ahead. We have this all done. We have some Sol in the account wallet. And what's kind of nice is if we go Solana address, this will pull our address from our actual key pair that we just created not too long ago. Obviously, just like any other crypto wallet, you do not want to share the actual secret phrase with anyone. But since this one's out in the open, it doesn't really matter. And one thing to know that's kind of interesting, it took me a while to figure out, is you can actually use these paper wallets that you create on your terminal. And if you use the secret key pair, you can actually import that directly into Phantom. The way you have to do it is, I think it's like Phantom wallet new, and then you have to do from seed, and then you give it the file. So that's how that works. All right. So one other thing we should probably know is we have Solana, and now we kind of want to look at the second thing that's probably a little bit more exciting to you guys is SPL's Solana Program Library. And this is how you create other different tokens. And that's kind of the basis of mints and other NFTs. Something that I'm particularly interested in is SFTs, semi-fungible tokens. That's like your game objects that have metadata, but there's more than just one. Non-fungible means there's only one. And I know I'm a little bit all over the place, so again, please call out if I'm over-explaining things or under-explaining things. But just to go over the last little bit of the CLE stuff that's going to be important is we're going to go SPL token, and this is kind of the other command that's going to be really helpful just in a developer standpoint, because what we can do here is we can wrap Solana, we can unwrap Solana, we can mint new tokens, we can create NFTs, we can do all this stuff right from the terminal. And what we can see when we get into like the higher level development stuff is we can actually call these functions from Rust, of course, and then we can call them from like Node.js or TypeScript, which is what I particularly use. But we'll just we'll create a NFT real quick, just because it's kind of fun. SPL token, and we're going to do mint, I believe. Not mint. We're going to, what is it called? Oh, create token. There we go. See, it's really nice to read the help docs. So create token, and it's going to give us this new token that we're creating. This is the actual mint account, and we're going to need that in a second. So copy, and what we can do now is we can actually mint from this account. Let's see. We're going to do SPL token. I believe we can just mint from it. Let's see, token amount. We're going to do 100. And one thing that I should have done in the create account is put decimals equal to 0. So that means right now it's all in LAN ports, which means it's going to look exactly like Sol it is, or it is. It's going to have a lot of decimal places. So right now it's like we have 1,000 Sol or 1,000 of these guys. Now, what's important to know is an SPL token by itself doesn't contain any real metadata, not like you'd see in NFTs, SFTs, and that standard is actually coming from a program that I'm sure we all are maybe familiar with, and that's Metaplex. And Metaplex is the NFT standard for Solana currently, which means if you go on like SolScan and you see like a photo or an image, that's actually pulling right from the token account that was created with Metaplex. So that's kind of how that works. And I know it's kind of a lot, and I'm throwing it out there. But at this point, I don't know what people don't know. And if you have questions, we can go over certain things. So, all right, now that we got those little basics done, we're going to actually create a little project. So we're going to go anchor init, and we're going to call it, I always spell diamond hands wrong, diamonds. That's definitely wrong. Okay, we're going to cheat and use Google. So one thing you should know about me is I am a terrible speller, but we're gonna go there, and there we go. So that basically pulls together our anchor package for us. And there's a couple things that I kind of want to go over in terms of like the structure of the actual anchor project itself, and a couple things I just kind of want to point out to someone who's maybe never touched this or hasn't had the time to explore it. But we're gonna let this keep running, and I'll probably end up opening up file, new window, file, another project just so I can pull from it. Let's just open up Raffle just to have it handy as we build up. And this is kind of interesting, but when I normally run this command, it takes a couple seconds, but running OBS, streaming, and this apparently is a little too much for the old computer. All right. Well, while we wait for that, Willie, you got any questions, thoughts, concerns, anything you kind of want me to go over as we hit it? Feel free to chime in, or anyone who else is watching. I imagine it's only Willie and I right now, which is perfectly fine. All right. So we have our diamond hands. Okay, I'm glad it's coming through mostly good. We'll have to figure that out at some point. But we're going to go ahead and open up Anchor Toml, because this is the place that I kind of like to start. A couple things to know here is right now we're on LocalNet, and what happens is when you actually use Anchor Test, which is really cool, is it actually spins up a validator to run Solana on your own local machine, which makes testing very, very fast, which is fantastic. The problem is if you're going to be interacting with any other programs on the Solana library, you're going to have to be doing that off of DevNet or, of course, mainnet, which gets expensive fast. So we're going to run on LocalNet just because my computer's already taking a long time. But just to note that when you're first writing the program just to get something to work, and if you don't need any other dependencies on Solana, LocalNet is fine. DevNet is your next step, and then when you finally push, mainnet beta. But we're going to keep LocalNet. We're going to talk about this in a second. Wallet, this is just that new wallet that we just created. And for tests, I actually don't use Yarn. So we're going to do TS node tests, and then I believe it's, let's do this. I just do straight up TS because when I write these things, I usually write the API in TS pretty much alongside of it. So I don't like actually running those big tests. So we're going to do that. Diamond hands. All right. So the important things to look out for here is, of course, tests. We're going to be removing a lot of this to something a little bit different. In programs, these are really the two files you need to look out for: tests and then programs diamond hands. I actually go ahead right away and create a new folder I just called TS, and this is where I throw this actual file. So I like I said, I like to create the API as I'm developing. No, wrong. Because when you're developing a Solana contract, part of it is getting it to work, and there's a million ways you can do it. But the way to do it with the client in mind is probably your best bet. So how do you make the front end developer's job as easy as possible, while still giving them the control? And that's the mindset that I very much use, because one, I do the front end sometimes too. And two, if people are going to use your program, it has to be at least relatively easy to use, or otherwise they're not going to. All right. So diamond hands, we're just going to make that a clear cut. We're not even going to look at TS right now. We're just going to straight look at, we'll do console dialog. And we should be able to do TS node tests. Oh, I should probably get into our directory, eh? It does not like that. Oh, probably because I don't have any headers in there. We're just going to go ahead and yoink some other code real quick. Here we go. Ooh, we don't want soul helpers. We're going to use this guy. Going to get rid of these. And we're going to get rid of these. We're going to go npm I. I should probably explain these two at some point. And we're not even going to do node wallet. Const main. There. The epitome of all tests. All right. So now that we have that set up, And I actually like to name this tests, go back into Anchor, and go to tests. Okay, so now that we have that out of the way, I like to change this right away. So right now, this is our program ID. Every program needs its own, basically, address. And when you first init a project, I believe it always comes out as this. But we're going to change that right away just to get it out of the way. And you'll see this in 3 different areas. You're going to see it in programs, source, and then this is our actual Rust program. This is what we're going to want to change. And we're also going to see it in Anchor, TOML. And then I usually have it in here as well. And we're just going to go ahead and come up with a different one. And don't worry about all this stuff. There's a couple other things. We're just going to get npm grab the Solana SPL token. Because like I said, we're going to be using that. And then I like to split Web3 and BN out as well. Again, I'm kind of rambling because I have a lack of plan here. But I swear, we'll get into the Solana dev in just a second. All right. But this is kind of the third place you're going to see that program ID. So we're going to go ahead and we're just going to go Anchor build. And what you're going to see is it comes up with this target file. This IDL, which is going to be important. But we're also going to see deploy once this gets finished building. And this is where I want to first start off, just to kind of get everything ready and nice before we go. And while that's building, we can probably start looking at these things. So like I said, everything is built off of accounts in Solana. Right now it comes up with basically this program only does this initialize account, or I guess function, and that's it. But that's not that interesting. So we're going to go ahead and take a look at what we'd want for a Diamond Hands account. So we probably want what are we going to want for a Diamond Hands? So we, the user, has some sort of NFT we want to store for some amount of time. And all NFTs is an SPL token that we have access to. So we're going to want to put that token that we get to choose into some sort of what we're going to call vault. And this is just an account that we spin up that basically holds that asset for us until a specific time. So that's what we're going to do here. And now that we have this all built, you're going to see that we have deploy and we have a key pair. So we're going to go Solana address key pair, and then we're going to go target deploy Diamond Hands key pair JSON. Going to take this is now our program address. We're going to put it here, save. We're going to put it in our TS file, save, and this is going to be called Diamond Hands ID. And then we're going to put it in the anchor dot toml. All right. Yeah. So, yeah, that's basically how staking works. Um, is when you stake a particular NFT, they can define basically kind of which family that comes from, or some underlying check that makes sure that it's the related NFT that you need. And basically, they lock it in an escrow account until a certain amount of time, and they can then, pay out a certain amount when you redeem it. So it's the exact same logic, right? The Diamond Hands account is going to be pretty much baby's first staking program, just without paying out anything else. But yeah, what you'll find is that Solana programs by necessity can't be that complicated, because you're limited to, I believe it's 4 megabytes of stack size, which is it's a decent amount, but it's not a whole lot. And you also pay for memory. So every account that's made on Solana, you actually have to pay for it to be there, and it's called rent. You have to pay enough rent for it to stay alive on Solana forever, because keeping track of data is expensive. And right now, what's kind of nice is all accounts are required to be rent exempt, which means they have enough money in the account that they don't actually get charged rent, but that enforces an upfront fee when you create the account. So if you're ever like on a website, and like I think I saw this for the first time when I went on like Orca. For the first transaction I made, they said like, hey, this is a one-time transaction fee. What was really happening there is you were creating an account for yourself to basically save your state, and allow you to make those transactions when you could. And we can get into all of that fairly soon. But the first thing that I want to do is bring up a couple things, and the first thing we're going to talk about is the actual like data structure. And I'm going to put a couple boilerplate things here, just to have. One thing that's important is, of course, error codes. We're just going to keep it simple. We have a general error that's going to be nice, like when things fail, and we'll be able to like add those in as we build out our logic. The last thing that I want to put out there that I found incredibly helpful, and I didn't find this out until much later and would have saved me a lot of headaches, is there is a test function where you can actually run functions without having to like deploy the entire program. Like if you want to test just bits of it, you can actually do that right from the file itself, and that is extremely helpful. So we're just going to keep that there for future use. I'm sure we're going to use it. And then we're going to be talking about accounts. Not accounts. Yeah, we're going to talk about accounts. And if you... And by... There's kind of two things. There's functions, and that's what we're going to see here, is what we actually run in our program. And then we have data structures. And the data structures is where interesting things happen. And if you're familiar with C, it's just like an actual struct, but there's a couple things here that I want to point out, and we're gonna call this. We're gonna be unique in calling it Diamond Hands Yeah, we'll just call it Diamond Hands account. All right, so this is the thing that I like to start off the programs with, is thinking about, all right, what information do I need to keep to make sure that everything will go as intended while still being safe. So, for example, if I made an account that had, um, you know, just the account that was holding the NFT without enforcing who the owner was, for example, anyone who had that account information could just transfer out that NFT. So those are kind of things that I like to kind of think about as we're building this up. So this Diamond Hands account, I think the most obvious one is going to be the owner, like who owns this. And this is going to be the person, who owns the Diamond Hands account. This would be like your wallet on Solana. And this keeps track of basically, okay, this is the owner of this account. We can check this every time that we access this account and basically limit functionality to it anytime it's called. So owner's pretty easy. We're also going to want what's called, what I like to call a gatekeeper. And he's also going to be a pub key. And the gatekeeper, what they do is basically think of them as like a robot that owns the accounts and can actually sign transactions on your behalf. So you basically build a robot that can do these things. And what happens is this gatekeeper is going to be the one that you give him the NFT, basically. And when it's time to get it back, someone has to sign that account, and the gatekeeper is going to be the one to do that. And that's a whole nother thing we can get into. But these gatekeepers are going to be PDAs, program-derived addresses or accounts, which means that when you spin it up, it's actually seeded off of the program ID and whatever else you want to throw in it to basically make sure that we can rederive the address without actually having a secret key. And that's really, really cool. So anyone could rederive gatekeeper. But here's the thing is when you derive accounts, it has to fall on a special curve. And if it doesn't, it doesn't count as an actual account. So what happens is when you create these accounts, and we can see this in a second, Solana or whatever program you're using to get the address, basically loops through until it finds an address that's suitable to actually do it. And that basically that index that goes down, we call a bump or a nonce, to be able to rederive that account. So we want to save that as well. Yeah, so the gatekeeper, it's not an automated escrow wallet. The gatekeeper is the owner of the wallet, and you'll see that in a second. We actually need to create the wallet itself, and we're just going to call that pub vault, and this is also going to be a pub key. So the owner of this vault is going to be the gatekeeper. So the gatekeeper has the authority, just like your wallet, you're the authority, like your private key is the authority of that wallet. So you can sign transactions and say yes, submit. The gatekeeper is a bot that controls the vault. Okay, and so this vault we'll talk about in a second. And I believe the last thing we need, without being too complicated in this, is we're going to want a basically a time or a date that we can retrieve it. So we're gonna call it. I don't know what's something diamond hand related. Um, you know, we're just gonna call it release time. I'm not that creative today. Re. God, I can't spell. We're just gonna say date to unfreeze. Yeah. There. Easy. Um, and one thing to know is Solana works off of Unix time, which, if you're not familiar with that, it's actually quite nice because it's standard across, all computers. So there are no like time zones, and it's basically, I believe it's seconds since epoch, which I could probably figure out why it's called that. Important thing to know is it's technically an I64, which means an integer. But I like to keep everything as unsigned integers, and it's just part of me being from the C realm. Things get really, really tricky when you start using signed values, and you really have to understand the underlying bits. The really nice thing about unsigned values is there is no sig bit at the very top end. So there really is no overflow. It just kind of rewraps around to 0. Just something you kind of have to keep in mind. But date to unfreeze. Is there anything else we want to keep here? Nope. So like we could also keep things like, how many if you're locking away, you know, uh, an SFT, or if you're locking away some sort of token. They literally all work the exact same way because every NFT, every SFT, every alt token in Solana is just an SPL token. That's all it is, which is kind of cool. And we actually don't have to do anything different. All right, so this is going to be our main account. And one thing to kind of keep track of is we can do a couple different things. One thing that this does a lot for us, this account header. But one thing you're probably going to see at some point is this. The anchor serialize and anchor deserialize. That's if you're using some sort of data structure, because the account basically does that for us. But if we wanted to do, I don't know, if we wanted to store, let's say I wanted this Diamond Hands account for all of my accounts, just create the account once and then add or subtract volts to it. I could make a we'll just call it a vault, and that's a bad thing to call it, but it's just to prove a point. We can do pub vault. This is pub key, and then let's do pub amount, and we're going to do U64. So all currency amounts in Solana are going to be U64s. Just kind of keep that in mind. But now what we could do is, if we really want to, we could do pub vaults, and we can make it into a vec or vector of type vault. And basically what this means is we need this, or want this anchor serialize and deserialize, because what happens when you run an account, basically these things are all pretty static memory addresses, and they have to get reloaded and serialized into something the program can interact with. And then when the program finishes or doesn't finish, it has to be serialized to basically restore onto the blockchain. So that's why that's important, but we do not need that for this type of program. All right, so now we're going to actually look at the functions. These are kind of where everything comes into play. We're going to go ahead and grab something that I've used before to make this escrow account or this vault. And then we can run through why it looks the way it looks. And I'm going to get rid of most of these things. All right. So we will use these in a second. All right. So we're going to recall this. All functions I like to kind of make a param structure for, just to kind of keep things neater. You certainly don't have to. I just like to. It kind of helps me keep track of what inputs go to what function. But this is going to be create Diamond Hands account is going to be what it's called, and then I always do create Diamond Hands account params. So what we're going to need for params here is we're going to need that nonce. That's going to be something we derive on the front end and give to the back end here. So we're going to put in pub nonce, basically just this, and we don't really have to do anything else. We could, give it, I don't know, the amount. Yeah, let's do this right away. We're just going to do pub date to unfreeze. We'll just make it pretty atomic. So when you create the account, you're going to get, it's going to take your NFT right away, and it's going to hold it until that date comes out. So we're going to keep that. And let's see. So there's a couple different ways. So these functions are kind of interesting in that you have to define all of the accounts that are added to it. And what happens is when you call a function on Solana, it actually finds all these accounts basically from their public key and gives you the data that they include. And it's really interesting how that works is you cannot you can't have in your program, if you give it a public key, it can't fetch the data, not in any meaningful way anyway. You actually have to basically call it with everything that it needs from the get-go. So the first thing we need or want is going to be the actual Diamond Hands account. You might be thinking well, we didn't make it yet, and you're right. So we're going to be doing that here. So we're going to do pub. I should have picked something else. Maybe by the end of this I'll learn how to spell Diamond Hands. This is going to be a account. We're going to do info, and then this is going to be of type Diamond Hands account. All right, and what this account 0 does for us is it basically says, don't let this function run if this account data has been initialized. It has to be 0. So there's kind of two different ways you can handle this. Is you can create and pay for the account creation right here, or you can pass in an instruction that runs first on the TS/JS side. But this is sufficiently simple. So what we're going to do is we're actually just going to create it on this side. And we're actually, I believe it's, one, we're going to do mutt. So mutt in Rust just means mutable, and mutable just means we can change it, and that makes sense. And it's going to be init, which basically means it's going to create the program for us, and since we are going to be the ones calling it, we actually signed for it. And one other thing we need to kind of put in here, I believe it's just init. Wonder if we can do space right away. Let's see if that's, oh, mutt cannot, right. Right, and then we have payer. So we needed to find who the payer is. Of course, like that's the person who's going to be paying for the account creation. And what we're going to do is we're going to put owner in right away, and this is going to be us. What's really nice is we have a thing called signer, and this basically guarantees that our account that we are sending in for owner has signer privileges, which means in some way, shape, or form we have access to its private key, which is pretty cool. Which means it has the ability to sign something. All right, so we're going to put payer equals owner, and then the space thing is interesting. The init. So what's also kind of interesting is we also need to include the actual Solana program to init in a function, because anything that we do actually uses the system program to buy the space from. So we technically don't need this here as long as we pass in the correct system program. But what's really nice about setting up these functions is we can basically do type checking well before the function actually calls, so it will fail right away if one of these constraints does not work. So address equals, so this basically means this address has to equal the Solana program, and I don't believe I have let's see, it's gonna be one of these things. I have that. We'll need SPL in a second. So actually, let's actually just take this out because we're just going to pass in and it's going to make it easier for right now. All right, so we have the actual like account, and this is the account we are creating, and it's basically we're storing this structure in Solana, and this is something that we're going to put together. And something I kind of want to put out there because it took me a while to figure this out. Basically, you pay for the amount of bytes that you need for storage, and what's really nice about this one is that it doesn't have anything dynamic. There's no vectors that we have to allocate space for, but just because I think it's a good exercise, we're going to make a function that just gets the size of this, just so we know what's going on here. So we're going to call it get DH size, and this is going to return a U size. All right. Turn 0. So just a couple things. So a public key is just like at its core, a pub key is just an array of 32 bytes. Like that's all it is. So that being said, 1 byte equals 1 byte. So we know that we're just going to type it out like this. Owner, we're going to do 32 plus, and we're going to call it owner. Then gatekeeper, same thing, 32. And again, this isn't necessary. It's just figured I'd teach it because it took me a bit. Nonce is a U8, which means 1 byte, 8 bits. So we're going to call +1, and that's going to be the nonce. Then we have another pub key. This is going to be the vault. And then we're going to do date to unfreeze, and this is a U64, so that is 8 bytes. Because I'm lazy. But there's one other thing that isn't immediately apparent, is there's actually a U64 or 8-byte discriminator for every program address. So there's actually like this hidden 8 here that we need to include for the size. That's not like readily available information, and what we can do now, if we so choose, is we can actually yoink this and put it into the space, and that will basically say like, hey, we are paying for this many bytes for this account. And if you really wanted to, you could pay it and add a bunch of bytes on for no apparent reason, but you'd be paying more. Then there's a calculation to figure out how much you'd actually be paying in rent. That's a function that's pretty well known. All right, so we have all these. But there's 2 other things. If we're going to be transferring it in right away, we actually need, of course, the gatekeeper. So we're going to do pub gatekeeper. And what's going to be interesting about this guy is he's going to be an account. But what's going to happen is we are going to, I believe, give me 1 sec. File, open, work wizard. We're going to go all the way back to my first, and there we go. Sorry, 1 sec. File. Here's where we want it. Open treasure hunt. And soul treasure. Okay. So what we're going to want is we're going to be creating that gatekeeper pretty much right off the bat. And what's interesting here is when we do that, let's see. Technically, we don't even have to create. I need to remember how this works. because we don't need to give it the nonce right away. We can actually just keep it gatekeeper for now. And we're going to be double checking that what we pass in is going to be correct. So that's going to be important. Also, it has to be a type account info without some other thing here. So with that, we're going to need a pub. We're going to need the vault, which is pretty self-explanatory. This is going to be an account of type info. And it's going to be of type token. And we do not have the SPL token library installed yet. So we're going to go ahead and grab that really quick. So what we have to do there is put that, and then in our cargo TOML, we're going to be adding in 2 new dependencies here. And one's going to be anchor SPL, which basically just gives us the SPL library. And then we're also going to use SPL associate token account. So how the associate token account is really nice because it's a way to rederive an address from basically a given mint and your actual wallet ID, and that's how you can actually keep track of, you know, whose NFTs are what. It's basically that's like the de facto address account that keeps your SPLs for you. All right, librs. So we have this, and we can probably even just do this. We don't need all that. And we may need to do anchor build. It's going to fail, of course, but it just needs to get this token in there, and that's what it did for us. All right. So let's get to this right away. This is going to be initialize. It's going to be of this, and then I do params of this, and it's going to be create diamond account. All right, so now that we got through all of that, we at least have this to start off with, and that's fine. I believe if we build this, method not found. Because this thing isn't correct yet. This is going to be token account. So the vault, this is what's going to basically what the gatekeeper owns for us. And we're going to put account. We're going to call it there we go. And this is the thing that's definitely really nice about these kind of headers, is we can do constraints. God, I'm bad at spelling. And just take a look at what's going on here. And what we can do, constraint, there we go, is we can say this vault dot owner, like who owns the vault, and we can make sure that it's the gatekeeper, and that's important. One other step I like to do that is not necessary, but you can actually basically make sure that it's also an associated token account. And I like to do that just to keep it clean, and so people can't like pass in non-associated token accounts and they somehow forget to be able to rederive it, and shit's lost that way. There's always a way to get it back. It just gets harder to do that. So if we go here and we go to there we go. We grab, here we are. This is what I'm looking for. And as I get a little better on camera, these things will be a little bit more apparent. But basically, we want this thing called SPL get associate token account. And basically, we can call it right in this function where we're saying, hey, we want this vault to have the associate token account that is derived from the gatekeeper and the mint. And then it equals the mint key as well. And that basically just verifies that, hey, this is where it's coming from. So now we're going to take that entire thing and we're going to yoink it and pull it over here. And this is going to be what's we're going to call owner vault. And this is the actual, basically, SPL account that we're pulling from that our NFT resides in to give to our Diamond Hand Vault. And a couple things we want to just double check here is one, owner equals owner. So the owner vault equals owner.key. That's important. So, you know, we're not trying to call it on someone else's. It would, of course, fail because they aren't the signer. But that's okay. And then I always like to check that it's get the associated token account. Just again, to keep things clean. And we need to make sure those match and that the owner matches as well. The last thing we are going to need is the actual token program to do these transactions. And that's important. So the system program allows us to basically buy the rent we need, and the token program allows us to TX or transfer actual tokens. So now I think we have it all. Another thing you can do, like if you really want to, just as a nice little check, you can do and owner vault amount is bigger than 0. So that's basically just saying like, hey, do you actually own the NFT? Like, it would have failed either way if you didn't have it, because obviously if you didn't have it, you can't transaction it. But you can do these types of checks just to kind of make it fast, right out of the get-go. I generally like to keep these for the actual functions so I can print out like an error message, but just know that you can do them from there as well. So, all right, now that we have all that, I don't believe we need anything else, because this is, of course, quite a bit. So now we can actually look into the actual creation of these things. And the first thing I like to do is I split out my functions into kind of 3 phases. One, set up variables. 2, I like to do checks. Then we do TXs. Well, then it's, I guess I have more steps. Logic, TXs, and then I do change state. So these are all things that I kind of like keep in mind. So the first thing that I like to do is do let, I need to stop looking at my old code. I'll get better at doing this. Trying to just do it on the fly. We're going to call it Diamond Hands account DHA just because I'm sick of tapping it all out. And we're going to do @mut, which basically means we're borrowing from the account to be able to change it. This is a syntax thing about Rust that's interesting. Oh no, you're all good. Yeah, it's there's kind of a lot to it, and like even at this point, even though I've been at this for quite a while now, it's always nice for me to like re-reference things to make sure I'm explaining them correctly, and yeah, it's a bit different, but as long as you're okay with me rambling, we're fine. So let DHA. This is Diamond Hands account, and we're gonna go CTX because this is the thing that's passed into us. Like these are all the accounts, but like made whole. And what's nice about this init is basically this piece of it all basically does some of the underlying work for us. It basically called create account as a function which creates this account and basically returns it to us, which is super nice. So we don't actually have to worry about that. CTX. So now we have basically a blank account. And also, I don't believe we actually even need the space. I think since this guy is static, as in there's no like vector or anything that could be dynamic, it should just know. Unless, oh, okay. So no, we do need space, because we would have to implement basically the size for this, and it's fine. Okay, so CTX dot accounts, and then we're gonna look for Diamond Hands. So all this does is this allows us to manipulate and check Diamond Hands pretty easy. The next thing I like to do right away is just get the date, and this is very quickly. We have this really neat function called clock get Unix timestamp, and like I said, I always like to turn it to a U64. If the current timestamp was ever an I64 and that wrapped over one, we'd all be very long dead, and I'm pretty sure the universe as it exists would have gone through a couple Big Bang cycles, because the amount of information that's stored in an integer at 64 bits is way out of our realm of understanding in terms of how long that actually is. So it doesn't really matter. I just like to keep it as a U64 because that's just what I'm used to working with. Let's see if there's anything else that I need, and I don't believe there is. So now we do the checks, and we're going to do if. Oh, one thing to note about Rust, kind of interesting, is what I actually kind of like about it is all variables are basically defaulted as what we think is constants or finals, unless you put the mut in there, which means you can't mutate a variable unless you like specifically say we can. And I think that's an interesting paradigm. It definitely lends itself to more like functional programming. So it's just kind of a neat little thing that's there. So the couple checks that we want to make is, of course, we already checked to make sure the owner is who they say they are. but I think we took out the check to see if the amount is actually what we wanted. So we're going to check that. And we're going to check one other thing as well. Okay, so this is one I always kind of like to yoink. We're going to do what I call simple checks and then count checks. And this is just a way, like I said, it gives us the ability to kind of give better error messages, because if something in here fails, like the vault owner and the gatekeeper key don't match, it'll just say I think it's a raw constraint was violated, which doesn't help you very much. But this piece of code, before we get into the thing, is basically just double checking that our gatekeeper is okay. So a gatekeeper is interesting to where it's basically just an address that's hashed or seeded with the program ID, this guy up here. And we can basically recreate this with the pub key create program address. And right now we are hashing it with the account. And what we can do is we can make this a little bit nicer. So let's say we have an account for each NFT that we want to do. There's better ways of doing this, but we can basically put whatever we want in here to get that key, as long as we still call it from the front end. So the only thing that's missing in terms of like a seeded address is the program ID. But we can actually just take this DHA to account info, and it's basically saying like, hey, we're gonna take this account, take its public key basically, and turn it into a buffer of bytes, and that's how we will derive this address. This nonce, of course, is coming from params.nonce, and we'll call that in the front end. But the problem here is the way this is set up is this gatekeeper will only be able to exist once per user. So technically this gatekeeper, once it's created in just this context, let's say you had multiple accounts under the same owner, technically he would work through all of them. It gets a little fuzzy, but basically we can change this up a little bit to where we seed it just a little bit differently. Oh, and actually, no, this is fine, because we're using this particular DHA to do it. So this is actually okay. We don't need to do anything different here. Forget I said that. We'll see these error codes, but remember we kind of started something, and what I like to do is I just put general error for everything until I get the program done, and then I can go back and like give it decent error codes, or when I start actually testing it. It just stops me from going back and forth for every time I have an error. So this is the only account we really need to check, is basically, hey, is this gatekeeper who we need it to be? All right, so simple checks. If, like I said, we can know ctx dot accounts dot owner vault dot amount is less than 1. We're just going to return this error. All right. Sounds good, Willie. Well, I'm probably gonna wrap it up at some point too. I think I'm going to probably program the rest of this function and then leave some of it for kind of where I pick up next. I know this is very long form for the simplicity of the program we're doing, but I figured in terms of short form, it's fine. So we'll pick up where we left off. I'll probably finish up this little bit here, and then we can look at actually using it and testing it in the front end next time. Yeah. So I think that's what's going to happen, because if I create this entire program tonight, I'll probably be streaming for much longer than I have to. But I appreciate you stopping by. It's fun for me to talk about, and I know I'm rambly, but it's yeah, I'll make sure to post it up to YouTube. It's gonna be definitely awful, but the thing is like what I found, and I guess why I wanted to do this is because I kind of wish someone was rambly and stuff when I was first learning as well, because there's really not a whole lot of information about Anchor, Solana, and development currently, not outside of just using the easily or accessible tools out there. A lot of it is, reading code and getting things. So that's kind of why I want to do this in the first place, is hopefully to be answer some questions, of course, learn as we go, and have something as like a reference, like, hey, I remember Coach Chuck like talking about this thing in one of his rants. Maybe I can like make that connection. So I'll be sure to post this up on YouTube. And it's going to be unfiltered, and this is going to be it. So I'll probably just power through this last little bit and get on to the rest of the night as well, and then get on next week and finish this up, and then the next week. I plan to just keep doing this as long as people want to learn, and it's interesting to people, or at least you. So awesome. All right, we checked this. We're going to also check. One thing I like to check is basically is date. Obviously, we want to be able to check to see that. Perfect. I'd like that too, and good. I'm glad you're liking this. Like I said, this is something I'm really passionate about, and it's fun to share. And it for me, it would have been nice to be able to like talk to someone or see them like on stream talking about this too. And I remember like surfing through old videos on like Anchor and stuff. On like, okay, like what can I take from here and from here to like stitch it all together. So awesome. Yeah, I'm gonna power through the rest of this. Gonna get off, get a good night's sleep, and I actually have to finish up a program for someone else tomorrow. So that's gonna be my week. Yeah, we're just gonna do date if it's this is date. I should probably just call this current date. One thing to note is Rust uses snake case, and that's kind of like a slither little snake, as opposed to like camel case, which looks like let current date, and it'll actually yell at you because it's like hey. Maybe it'll yell at me. No, it doesn't yell at me. It yells at me somewhere else. Awesome. Well, definitely do what I can to make it there on Monday. But you have a great one too, man, and we'll be talking soon, I'm sure. All right. If current date is less than, is bigger than params dot date to unfreeze. Basically, we don't want this thing, we don't want to put it in there just to be able to take it out right away. That kind of defeats the entire purpose. And we could actually enforce it to where, hey, there's a minimum amount. So we could do something like this. Min freeze time, and this is in seconds. We're going to call it 60 times 60. So 1 hour. Yeah, 1 hour times, I don't know, we'll say 100 hours. That's going to be our minimum. And then we can do, I forget exactly how we do the consts. U64. There we go. It's going to be 100 hours. So basically, if the current date plus the freeze time is bigger than the date to unfreeze, we're just going to throw an error. So it won't actually go through. And I don't believe there's anything else that we need here. Logic, we don't really have to do much because we're only going to be transferring the amount. And actually what we can do is in params, we can make this a little bit more robust. We can put amount U64. So let's say we have like a token we wanted to do as opposed to, let's say, an NFT. So now, instead of 1, we can basically say, hey, if it's not bigger than the amount, if the amount we want to transfer is bigger than what the owner has, we're going to fail it because whatever. Oh, obviously super important, and this is like the genius behind it, is programs here are basically in a sense atomic, which means if they fail, they just completely fail, nothing gets changed at all. But if they succeed, they're verified and it succeeds. Like that's like the basis and why the programming of this stuff is so cool. Is you can guarantee that the entire thing succeeds or the entire thing fails. So like if I were to change part of the state and like first and then we fail it, it doesn't matter because the state won't actually update on the blockchain. So that's like the coolest part. We can basically, it basically gets rid of concurrency issues, which is awesome. All right. Current date, min freeze. Pretty easy. There's not really any logic we have to do. It's basically just like, hey, we're gonna be taking your asset that you passed into us, and then we're going to go ahead and I know I'm just yoinking this from other stuff, but we're going to talk through this. So CPI accounts, we're just going to be doing a transfer. And this is, so CPI is cross-program invocation, which basically means like, hey, we can talk to other programs on the Solana ecosystem, which is great. And this one, we're particularly talking to the Solana token program, which is what we want since we're going to be transferring NFTs and or anything else, any other tokens that we might want. So we're going to do from, and of course this is going to be from the owner vault. And remember, any sort of like NFT, really, anytime you have a token or something different, you actually have a separate wallet that keeps track of that. And that's where the associated token address comes from. And that's what we're actually transferring from. Like your main wallet doesn't actually hold any tokens. It can just be used to derive your associated token addresses, which then hold their tokens. Yeah, it's super not confusing. I mean, it makes sense in my head because I've been here for so long, but it's kind of tough to explain, which generally means you don't understand it enough is the general consensus if you can't describe it to a 3-year-old. But anyway, so from owner vault to just the vault authority, and this is going to of course be owner. CPI program, cross program invocation, that's going to be the token program. And then the CTX, the context, is going to be the accounts. So these are all the accounts that we basically are sending into it. And on their end, it looks very similar to like where the Diamond Hands and Gatekeeper, like that's what these types are, the from, the to, the authority. And then we do token, and I don't know why this isn't coming up for me. I wonder if it's just transfer at this point. Huh. Yeah. So since I have this, that's all I needed. And then this is basically, it's the context, and then we have the amount that we want to do. Again, everything's in U64. And with LAN ports, it's interesting because like the decimals between different the decimal places change on like the token side of things, but the LAN ports don't change. So if you have something decimal 0, for example, one LAN port equals 1 token. But if you had decimal 10, or let's say 2, 100 LAN port would equal 1 token 0.00. So that's kind of important there. You can the LAN port's actually kind of interesting. You can look up in your own time why it's called that. But we're going to do params.amount. So basically, I like to transfer all the tokens and stuff before we actually continue on. And basically, I like to check if it's okay. And if it is or not, we throw the general error. Because this actually gives us a program error. I think it would just fail if I don't do this, but for me it's kind of just reassurance. And then state change, this is kind of probably the most important part, is what are we changing in the state? And we actually haven't even like initialized the DHA state at all, so we pretty much have to do that. So like the accounts created, we have all like the space to do stuff with. Now we just need to assign all the variables. So let's see what we have here. I always like to just copy what the account has, and then we just kind of go from there. So DHA owner equals ctx.accounts.owner.key. So we got 1. Then we do, of course, the gatekeeper. And what this does is like when you call it on the front side, keeping these accounts, like technically you wouldn't even need to pass these guys in because like you don't have to pass them in. It's just nice to call from the standpoint so you don't have to rederive things every single time. It's just you keeping that pointer to itself, especially for the cost of the space, I believe is worth it, and just takes away the headache, especially for people who are using your front end code. Be like, oh, okay, I just repoint it this way. DHA gatekeeper, DHA or CTX. So I like to keep pointers to all the relevant accounts like in the program itself. It just makes it easy, nice. Gatekeeper dot key. Yeah, because technically the only one, the reason I keep, or the reason I kind of pass gatekeeper in here is to basically check. And sometimes you'll see, you pass in an account just to make the checks that they are who they say they are. So basically this vault, we know the gatekeeper is the owner, because if we pass in like another vault where someone else is the owner, and we got to the point, basically they would have to sign to get your thing back. dha dot nonce equals params dot nonce add dha dot vault equals params dot vault, and then dha dot date to unfreeze equals params dot date to unfreeze. Oh, right. ctx dot accounts dot vault dot key. Also, the beautiful part about working in VS Code is, of course, auto completion, which saves a bunch of time. So, all right, there you have it. This is how we would create the actual Diamond Hands account. And just to see if we can get something quickly working on the front end, we're going to go to tests, and we're going to go to let's see if we can grab this real quick. File open, and this is just a quick way to make sure things are working. Soul Coffee, smart contracts. And we're going to go to here we go. We're going to yoink some code here because it's always easier to yoink code. Go to tests, and we're going to go ahead, get rid of all of this. All right, we're going to just call this provider. So provider is something like you can, like on the front end, you can grab from like a Solana wallet or just a key pair. It's basically a way to provide your wallet and to be able to sign things. Set provider, program. This is going to be called Diamond Hands, and const. So this should look okay. Just have a couple includes here. So helpers we're not going to need, and we're not going to want that anymore. So how we would call this is we'd go program dot rpc dot trying to do this all off memory. Yeah, and then it's just the create WRS create Diamond Hands account. And there's two things that we're going to need here is this first piece, of course, is like the entire like object that we're passing into it, and the object has parameters. So parameters just go in like regular, the accounts, and that's going to be an array. No, that's going to be, it's going to look like this. And then we're going to have our signers. And we're going to touch on all this later because I don't feel like... okay, we're close. We may as well. Alright, so this first piece is going to be this thing right here. It's going to be our Diamond Hands account params. So we're going to go ahead and put nonce, and that's going to be our nonce. We'll have that in a second. We're going to have date to unfreeze. And one thing that's important is Anchor basically will give out an IDL, and it will change everything that's snake case to camel case, which is nice. And we're going to do date dot now plus 60. And so the thing is in TS.js, date.now is actually going to give you milliseconds. So we're going to have to divide by 1,000 to get it to the Unix time seconds, plus 60 times 60. So hours times, let's say 200. So there we go. And also important is this is actually what's called a BN, a big number. And why that's important is TS, I don't believe, natively supports U64 or 64-bit integers. So we actually wrap it in this BN. You don't have to do it for any other number. It took me a while to figure that out, though, when I was first doing things. And then lastly is the amount, which is also a U64. And we're just going to say 1. But it also has to be a new BN, by the way. The reason I use TypeScript is like when you kind of get into these things, having the typed piece is going to be very, very, very helpful. Okay, so basically we have all of this. We're going to do that nonce in a second. These accounts are going to be pretty important. So let's go ahead and grab the accounts that we're going to need. Yeah, it's going to be all of these guys. All of these guys. Tests. Let's see, the Diamond Hands account. This owner vault, and then signer. Okay, so let's start from easiest to hardest. The system program, which let's see if I'm doing that right. Yep. So system program, of course, this is like Solana itself. We're going to go do that. And these are expecting pub keys. And that's going to be, let's see, web3 dot system program dot, I want to say ID. There we go. So that's the easiest one. We're also going to need the SPL import all as SPL from, there we go. So and these I don't believe have to be in order, just as long as it matches, but I like to do it in order. Program, this is going to be SPL dot token program ID, pretty easy. Then we're going to have owner, which is going to be us. We are going to be the owner. This is going to be provider dot wallet dot public key. Then we have the vault, and this is going to be interesting because we have to grab that as well. We're also going to have to grab the owner vault, the gatekeeper, and the diamond hands. So the diamond hands itself, we actually have to create that program ID. And what I would actually usually do for something like this, I would split it out into another function just called create diamond hands account. But we're going to keep it all here and we can clean it up later. But we actually have to diamond hands account, call it that, and we're going to go web3 dot keypair dot generate. So this is actually like an actual wallet, a key pair. We don't actually ever use the private key, and what's nice is in this function is like you can keep it to close the account, or you can just let the private key go off into the sunset and no one will ever use it again. So we're going to do that, dot public key. And now what's going to be important is we actually have to make the gatekeeper. And that one's a bit interesting. And to do that, we use anchor web3 public key find program address. So basically what this does is we find the program address that is associated with our program with the account that we create. And that's this DHA public key. So like this is our diamond hands account, and it uses that diamond hands account as the seed, and it basically returns the public key of the gatekeeper as well as the nonce, which is basically it's the bump, the thing that like as it iterates through its list until it finds an actual key that's okay, this will return it. And usually it's 255 because it's only a U8, and it will go down until 0. And there are times where it can't find an actual nonce, but I don't even know the statistics of that happening. It's unlikely though. But that's how we actually get the gatekeepers. Like we just derive the address, which is important to know. So the gatekeeper itself doesn't actually have like information. Like it's not a true account, I guess. That's not entirely true, but all we have to know is that's how we pass it in there. And now we have that nonce that we were looking for. Let's see, what are your problems? Property assignment. Was that how this works? No. So the people who actually have to sign this, is since we're creating it, we actually have to pass in the diamond hands account, which is fine. Now what we have to do is we have to get the associated token account address, and to help out with this, I'm going to be grabbing some helpers that I've made in the past, because there's kind of a decent amount of actually creating an SPL. So we're going to go into we're going to see why this so that's what's making the noise. There we go. And then instructions. In instructions. All right, we're going to ignore this. So these are instructions that are going to run that we want kind of all together. So it's either all going to complete or it's all going to fail. These are extra things that we can throw in, and we're actually going to be using this to create the SPL token account for the vault right away. So vault, owner vault. We're going to go ahead, file, open, and then I am going to be done for the day. Going to go to anchor. Dronies, candy, anchor, treasure hunt. Go here, and we're just going to yoink some nice helper code. Soul helpers. And I'll kind of explain why I'm yoinking this in a second. And I can go through all this. I know I said I was going to go completely from scratch. But I just want to get this running for now, and we can go over what these things are soon. Yes. And we're also going to do one better. And for some reason, I don't know why this is the case yet, but if you use the latest version of the SPL token library, a lot of these things look different than what the Metaplex SPL library actually uses, and for that reason I use a lower version of the SPL library just to match up with what Metaplex and everyone else is doing, just because that's the most useful case. And the problem is like I actually like what the new SPL library does, and that's why there's errors right now. But if we install Metaplex, it's going to go ahead and resolve these, because it's basically going to force a lower version of this SPL library, which, you know, we'll take, I guess. And I just want to double check. Turn on Vault, Soul Helpers, TS. And I think it's actually when I use the Metaplex. Which will be fine because we'll probably use it at some point anyway. Alright, see, they resolved everything because they use a different thing. But basically, this is going to allow us to create some SPL tokens right off the bat. And I did this because, you know, I'd have to like run up things, and it's just easier to have these helpers for now. And if you want, you can certainly have that file. I might make it into an NPM repository at some point, just because I think it's typed a little bit easier. All right, as helpers from, there we go. All right. Now, we're basically going to create NFT for us real quick because I think that's important. Helpers dot create SPL, and we're going to go ahead give the provider, which is us. We're going to give the amount. We're going to give it 1. I defaulted as decimals equals 0, so we're going to have 1 NFT at the end of this. And this actually, if we go into this function, it's going to so how an SPL is created is you first have to create the account. Then you have to init the mint, and this is the decimals 0. Then you actually have to create the associated account, and that's the wallet that you own that's associated with the mint. And then you actually mint the token to your account, that associated token account. So this should actually return us SPL token info. So we're going to do let NFT equal await that. And let's see what we have here. NFT, okay, perfect. We got everything we need. But now we also have to create the vault for the gatekeeper. So let vault equal await helpers dot get associated token address and should create. I think that's important. That is an actual built-in function. But again, when I was dealing with like the versioning issues with using like a Metaplex, or I was using like Switchboard, it reverted to the old one where this function actually wasn't a thing for some reason. So I made my own. But we're going to go provider, anchor, so the actual mint, and that's going to be our NFT.mint, NFT.mint. See, this is why TS is great, because of that auto completion. Owner, so this is actually going to be gatekeeper, because the gatekeeper is the one who's owning this one. And this last piece is important. We're actually going to allow it to be off curve, because it doesn't matter what the gatekeeper is, as long as we have an associate token account. And since a PDA I don't believe I think it's meant to be completely off curve, like this is why that's there. So we actually have to be true for anyone who's a gatekeeper. So now that should have the rest of what we need. So owner vault is NFT dot public key, I believe. And then vault is, of course, this is going to be vault and should create. And that's going to be that. NFT dot address. All right. So there's one last instruction that we have to do, and that's this should create. So we have our gatekeeper. This is great. But the thing is like we need to create its associated token address that matches this guy, and that's what we check in here. And actually, this is the last thing we should probably do is owner vault dot mint equals vault dot mint. So this assures that both of these mints equal each other. But we actually have to create this account, because that account is not free. So we go ahead and in instructions, you know what, I'm going to see if I can. Now we're going to go back to helpers. I'm getting tired. I believe I actually have the get associate token address. I don't. But this is actually the instruction that we need, is this create associate token account instruction. So we're just going to yoink that. And we're going to put the stipulation. We're going to put this in brackets. So basically this is going to be an array of 1, and we're going to do if should create, which, like, there's not going to be a scenario where you don't have to create it, but it's nice to have this. So if should create, we pass it this array. If not, we pass it in an empty array, and then we do the ... which basically just adds it to this array. So create token or associate token account instruction. God, that's a mouthful. Associate token ID, program ID. The mint is going to be the nft.mint. The vault, let's see. So we got associate program ID, mint. We're just going to do this, make it a little bit easier on ourselves. So mint, associate token account. This is going to be, right, vault, and that's the thing that we came up with earlier. The owner is going to be gatekeeper. The payer, this is important, is going to be us, so provider dot wallet dot public key, and then that's it. So that's going to actually create the associate token account for the gatekeeper. Awesome. On true, and that should be it. So we're going to do await. This should run just fine. And then what we're going to do is we're going to go ahead and print it out. So let's do console.log program. So when things are on the front end and you actually get to use the IDL, which is awesome, it gives you some really nice things where it will actually it uses like an internal coder, which basically takes like the raw data and turns it into a JSTS object that you can play with. So this account is going to be of type, if we go lib rs, it's going to be a type diamond heads account, tests, and then right, wait, come on, autocomplete. Maybe it's just account. Program dot. Oh, it says any as anchor dot program anchor dot IDL. There. Now this should give us some. There we go. Account. It's gonna be of type diamond heads account. And I forget where I was because your boy's getting tired. Tests. There we go. All right, and now what we can do is fetch, and we actually get the address. So this is going to be diamond heads account dot public key, and that should print out our actual account address. So console.log creating SPL, or let's call it NFT. This is going to be getting gatekeeper vault, and then calling create. Alright, and with any luck, we didn't screw up literally anything. And it's just going to work. Remember, in Anchor TOML, we have the test as tsnode test tests. And what's really nice is since we're on LocalNet, it should just build. And if we do Anchor test, it's going to build everything and run the tests for us once it has been deployed. So it did not like that. Fields must be array layouts. Initialize mint. Alright, so it's complaining about something in my helpers function. What we're going to do is we're going to actually downgrade. I want to say it's 1.8. I want to believe npm I. Let's try that. This is a quick fix. Let's try that. Huh. Oh. Right. I should probably call run main A. And let's see if that does what we need it to. All right. Owner vault not provided. Got it. Remember, not snake case, camel case. All right. Token program. It certainly is. So it's saying something's missing, basically. Let's see what's missing. That out. That out. Let's play a fun game called Count the Accounts. Alright, Diamond Hands, got it. Gatekeeper, got it. Vault, got it. Owner Vault, got it. Owner, got it. Token Program, got it. System, Program. Looks like everything's there. And we're going to fix this right away just so it stops yelling at me. Token program not Vault, Diamond Hands, come on. So we can always take at IDL and take a look. Diamond Hands, Gatekeeper, Vault, Owner, Token, Program. I wonder if I spelled that wrong. Ah, I did. You guys at home were probably like, oh, this guy's a big dumb idiot. And you'd be right. Oh, there we go. How neat. Alright, so like I said, that nonce was 255. Let's just say the 255 nonce didn't work. It would go to 254 and then so on. And what we can actually do is one better. So like this is our day to unfreeze. So if we were to have made the actual unfreeze call, we can of course, try to call that and it would have failed but we haven't made that yet. So that's the account. We're going to go ahead and just verify that the vault, and this is the thing that's owned by the gatekeeper, actually has the NFT now, or at least has an amount of 1. So we can quickly do that, and then I'm going to sign off because I am tired. Console.log, and it's going to be this is going to be a helper function as well. Await helpers dot get SPL account and provider provider mint is going to be nft dot mint, and vault is going to be vault. Oof. There we go. Alright. We're going to await that. Then grab the amount. So with any luck, this should equal 1. And if it is, then today would have been a success. And again, one thing to note is I am running on LocalNet, which is fantastic because it's much faster, and I'll show you just in a second how much faster it is. So right here, Gatekeeper's NFT count equals 1. Awesome. And just as a thought process for you guys, if you are going to be doing this off of DevNet, which is going to be more helpful the closer you come. And again, this means that we're actually going to do one better, and we're also going to do owner's NFT count. So there we go. So now we're going to see that the owner has 0 and the gatekeeper has 1. Invalid account mint. Oh, right. NFT.address. And while that's running, go back to Anchor Toml and DevNet. So NFT, the owner equals 0 and the gatekeeper equals 1. So that's exactly what we wanted. We transferred it to the gatekeeper, and literally no one else can get that except for us. Then now we change these things over to DevNet, and just as a last little test, I'm just going to show you how long it takes to actually put it on DevNet. So what happens here is it's actually taking your .so file, which is like the compiled Rust program. It's uploading it to the DevNet chain, and it needs to basically verify. Anytime you upload a program, it actually costs you a decent amount of SOL to do that. And if you're ever deploying something and it just fails out, one, pay attention to your terminal because you can get that money back, because it will take it out eventually. but the rule of thumb is put double what you think you need in there. So if it says like 2.3 Sol you need to upload the program, put 5 in your account to actually upload it. It took me quite a while to figure that out. When in doubt, just put more Sol in. It won't take that entire amount, but it's just important to have that. So now you have all this. It's deploying, which is great. And then there's one last thing I kind of want to say or show you. So we got the deploy success. So now it's basically just running the program, but everything's going to be taking longer because it's actually interacting with the DevNet as opposed to the local host. And there we go. We got the same thing, which is great. But here's the really, really cool thing is on the front end, what you have to do if you're a little uninitialized is you're going to have to take this IDL file and basically import it to every front end place just so they have that nice file. But what Anchor does is they actually have a program that allows you to fetch it right from the blockchain. And I found this to be really helpful just to keep everything clean. So if you do Anchor IDL init, basically create the Anchor IDL account. Then we do file path, which is going to be deploy target deploy target IDL diamond hands just JSON, and then the last thing it needs is this address. And basically this allows us to call a function. Let's grab it. Get program. And this is the really nice function is you are able to diamond hands. So there we go. We did that. And in our front end, when we get away from this provider or Anchor equals provider environment and use like the Solana wallet, you either have to import that IDL file or you can call a function called Anchor program fetch IDL and pass it the let's say in this case it's this guy, new web3.public key, and that would actually pull in the IDL file for you right from the blockchain, which is great. The thing that you have to pay attention to there is you have to be conscious of updating the file, and all you have to do that is Anchor IDL upgrade file path target IDL diamond hands, and then of course that, and that will update it to the latest version. So if something's not working, you're like, oh man, this totally should work, and you're using this call, just make sure you update the IDL. Well, oh boy, woof. You know, 2.5 hours, that's not so bad, eh? But we're going to leave it there. That's it for the day. I think that's a good place to stop. We got a program that's working, and basically, like I said, what we did is we set up all of Anchor to do what we needed to. We set up a TS kind of test script, and we created the startings of a program that basically, like we said before, baby's first staking account. But basically, it's going to take this account from the user and hold this NFT or this SPL, whatever it is, for as long as we want it to, and we'll go from there. So yeah, that's that. I hope you have a great night, and uh, feel free when I put this up on YouTube to scrub through all of my rambling. But hopefully, it's enough information just to have it out there. Like I said, there's not a whole lot of information out there right now about the Solana space, Anchor space. Like, you can read through a lot of things, but I always find it really nice to have like a video where people are going through things, making things work, break, and it speeds up the learning process. So hopefully that is helpful. I plan to finish up this program. I'll finish up the program next week, and then we can look at, creating maybe a front end to just make it look a little prettier or something like that. But yeah, either that or dive into the more fun programs. All depends. All right, y'all have a good night.